Okay, so I want to do a video on measurements. Okay, and this is generally meant to go along with a general chemistry lecture. So what I want to do is spend most of this conversation talking about the units of measurements, and I will actually talk. Let's develop this a little bit first before I show you the rest of the page. All right. So the units of measurements. We're doing our work in the United States, and likely that most of you are most comfortable with units of measurements that belong to the English system, which is great. Love it to death because it's familiar to me. Inches, feet, miles, right? Pounds. How do you spell pounds? With an L? LBS, okay. Pounds, all right. Those are from the English system. Can you read my writing? Well, in chemistry and physics, we don't use the English system, which actually I'm totally fine with that. As much as I like the English system because it's familiar, it's pretty. I also like the SI units, which are the international system of units. Okay, so this is the standard units. Okay, and I want to talk about this both from a couple different vantage points. Number one, I want to first of all say I want to use this term because I'm going to use this in class. Dimension and the unit that goes along with that dimension. Okay, and they're not the same thing. They refer to the same idea, but they're not the same thing. So if a dimension is length, what is the standard unit for length? My feeling is, I'd like you to guess that there. My feeling is you probably know. It's meters. Okay. If the dimension is mass, what's the unit that goes along with that? Kilograms, you're right. What is it for time? It's seconds. And what is it for temperature? It's kelvins. Alright, oftentimes we will use degrees Celsius. It's legit to say degrees Fahrenheit, although that's English. I say it's legit. We talk in degrees Fahrenheit, but it's not a standard unit. Seconds, the abbreviation we use for that is S, kilograms, KILOGR, you know how, and meters, the abbreviation we use for that is small m. Okay, be really careful now, right? Because mass, the variable we use for this is a small m, right? So you have to be very careful when you're using. You got to know if you're using dimensions or units. And my feeling is if students don't make that mistake very often, not a real big deal, I guess, but you do have to watch out for that. This small m means mass. That small m means meters. How can you tell the difference? Context. All right, and I guess we use a length for that, or time. We use a little t for that, right? And temperature, we use a capital T for that. All right, so those are dimensions, and I don't think I want to say much more about that. Just in terms of measurements, we're going to be using for these four, these are by far and away the most common four dimensions that we're concerned about, we're going to be using these units. There are a couple other units that we're concerned about, and that's derived units. I'll say more about that in a second. I forgot to say about the prefix multipliers. The prefix multipliers are things like kilogram, nanogram, decimeter, okay? And so we have a list of those. I'll write those out in a second, I think. Sort of depends. There's a table in any book that you're using, you could be using, there's a table of those prefix multipliers. But I'm going to give an example of that in just a second. And then finally, before we go on to that, I want to talk about derived units. And those derived units are volume. And the unit of that, the dimension is volume, pardon my handwriting, volume. And the unit is liters. And another derived unit is density. That's a dimension, sorry. And the unit is grams per cc, or grams per cubic centimeters. This is the same thing as grams per mil, because a cubic centimeter is a mil. And it sort of depends on who you're talking to, what units they want to use for density, but the standard units for density are grams per cubic centimeter. Okay, let me say something about prefix multipliers, and then we'll be done with this measurements video. Okay, so let's go the ones in the book start with exa, which I don't want to get into. I don't want to do all these. Peta, tera, giga, mega, kilo, deci, centimeter, or not meter, but centi, milli, micro, pico, or rather, oops, nano, pico, femto, and atto. Okay, so of course I'm not expecting you to memorize all these, but these sort of maybe in this range right here you ought to memorize. Okay, so let's go first of all here to a kilo. This is a good reference point. I think most people know what a kilo is. This means 1,000. Okay, so kilometer is equal to 1,000 meters. Okay, a deci means 1/10. A centi means 1/100th. Okay, a milli means 1/1000th, which is equal to 1 times 10 to the negative 3. So a millimeter is equal to 1 times 10 to the negative 3 meters, right? So all you got to do is just cross that off and put 1 times 10 to the negative 3, and you'll get that, right? So a micro is 1 times 10 to the negative 6. So a micrometer is equal to 1 times 10 to the negative 6 meters. So micro means 1 times 10 to the negative 6. And kilo means 1 times 10 to the 3, or 1,000. Mega, and I put these in order so you can get these, okay, 1 times 10 to the 6. So a mega meter is equal to 1 times 10 to the 6 meters. All right? And a decimeter and a centimeter, I think you get that. So a nanometer is 1 times 10 to the negative 9. A picometer, 1 times 10 to the negative 12. A femtometer, 1 times 10 to the negative 15. An atto is 1 times 10 to the negative 18. I've never talked about an atto anything. When I did my research in graduate school, we did do some femtosecond time steps. We did picosecond time steps, nanosecond time steps, and microsecond time steps. In my research, we never did any millisecond. But I think you can get the idea of how this is going on. Okay, so these are the, what did I call those a moment ago? These are the multipliers, prefix multipliers. And so you're going to have to be able to convert from, let's say, meters to millimeters. That's going to be a really common question for you. Or from nanoseconds to seconds. Okay? Those are some really common questions for you. So let me give you a quiz here. I won't even give you the answer now. Let's say you've got 4 meters. How many millimeters are those? And let's say you've got 1,500 nanoseconds. How many seconds are that? 4 meters. How many millimeters does that give you? Actually, I'm going to ask you to pause the video here, and then I will come back and give you the answer, okay? So pause here. Okay, let's suppose that you just paused, and let me solve this for you. 4 meters going to how many millimeters is that going to be? 4 meters. What I'm going to say is milli means 1 times 10 to the negative 3. And so the milli is going to go in front of that, 4 meters. So this is going to be 4 times 10 to the negative 3 millimeters. Just threw a unit in there for you, okay? Then the next question, 1,500 nanoseconds is going to give us, let's see, a nano. Got to cross it off now, right? Crossing things off is 1 times 10 to the negative 9. So this is going to be 1,500 times 10 to the negative 9 seconds. Now, I can just take the decimal point and go 1, 2, 3. So it's 1.5 times 10 to the negative 6 seconds. Okay, so there's the best answer. And hopefully that is helpful.